Good morning, how are you? I hope to be fine. Today we will discuss the last lesson in the Unit 2 for Secondary 1, first term, how to calculate the mass percentage of an element in a compound, or the mass percentage of an element in a sample. Mass percentage can be calculated from the equation which is present here. Mass percentage of an element in a compound equal in mass of this element in a mole of a compound divided in molar mass of this compound, for sure divided multiplied by 100. We can take an example to illustrate this calculation. Here, calculate the mass percentage of the components of potassium sulfate salt. Firstly, we must write a correct chemical formula of potassium sulfate. This chemical formula is illustrated here, K2SO4. So each 1 mole of potassium sulfate contain 2 mole of potassium atoms, 1 mole of sulfur atoms, and 4 moles of oxygen atoms. When we calculate the molar mass of potassium sulfate, it will be 174 gram. So, to calculate the mass or percentage of potassium in potassium sulfate, we will divide the mass of potassium in this chemical formula 2 by 39, divide 174 multiplied by 100, so the percentage of potassium will be 44.83%. To calculate the mass or percentage of sulfur, again repeat the same step. Divide the mass of sulfur in this chemical formula divided by the molar mass of the compound multiplied by 100 and calculate its percentage. Again, repeat this step for oxygen. To be sure that your calculations is correct or are correct, the total summation of all percentage of all elements will be equal 100%. Here we will transfer to another topic, which is called empirical formula and molecular formula. The molecular formula, it is the chemical formula which illustrates the types and the number of each type of atoms or ions in the chemical formula or in the compound. For example, chemical formula of glucose 6H12O6. This is illustrate. Glucose molecule contains 6 atoms of carbons, 12 atoms of hydrogen, and 6 atoms of oxygen. This is molecular formula. If we divide this molecular formula with a common coefficient, which is 6, to simplify this chemical formula, we will produce the empirical formula. Empirical formula, which is CH2O. The empirical formula, it is a chemical formula. Illustrated type of atoms which enter in the compound and the ratio of this atom to each other in the structure, but only illustrate the type and the ratio with simplest integer numerical ratio. So empirical formula can be common between more than one compound. How to calculate the empirical formula? We can calculate the empirical formula as in this example. Here we asked to calculate the empirical formula for an inorganic compound formed of carbon and hydrogen elements only. If you know that the mass of percentage of carbon in this compound is 85.72% and that of hydrogen is 14.28, So, firstly, we must calculate the number of moles of carbon and hydrogen. This number of moles can be calculated from the relation illustrated here. The number of moles of element equal in mass of this element divide the gram atomic mass of this element. Mass of element, we will consider the the percentage of each element as its mass. So we'll put the numerator. Gram atomic mass, which is given in between brackets with red line, will be in denominator. The result of this division, we will produce the number of moles of each of carbon and hydrogen. The second step, we will take the lowest number of moles, in this example for carbon, and divide both carbon and hydrogen moles by this smallest number to calculate the ratio of each of them, carbon and hydrogen, in the empirical formula. So we can find that the empirical formula for this compound is CH2. On the other side, if we given the empirical formula and we calculate the molecular formula, we will follow these steps. In this example, calculate the molecular formula of styrene, knowing that its molar mass is 104 gram per mole and its empirical formula is CH. Firstly, we must calculate the molar mass of empirical formula, 1 by 12 for carbon plus 1 by 1 for hydrogen, which result in 13 gram per mole. Secondly, we will find the coefficient which must be multiplied by this empirical formula to find the molecular formula. To do this, we will divide the molar mass of the compound on the molar mass of empirical formula to get n, or the coefficient. By multiplication, or write empirical formula between bracket and write it down 8 on the on the right side, we will write the molecular formula as written here, C8H8. Okay, now we will transfer to how to calculate the actual yield of an chemical equation. The actual yield, it is the mass which is produced practically in the lab when we make a chemical reaction. This actual yield in the most cases will be smaller than the theoretical yield, which is calculated by equations on the paper. There are many reasons to this difference in value between actual yield and theoretical yield. For example, reactants may contain impurities. The product may volatilized. Some side reactions may take place, resulting in the consumption of a part of products. Finally, some product may sticking in the walls of the reaction container. All of these reasons may cause the decrease in the actual yield from the calculated one, which is called theoretical yield. We will use this relationship to calculate the percentage of actual yield. The percentage of actual yield equal the practical yield divided theoretical yield multiplied by 100. As in this example, methyl alcohol CH3OH is prepared according to the reaction. The chemical equation is given and it is a balanced equation. Then he asked me to calculate the percentage of actual yield of the reaction. If you know that when 1.2 gram of hydrogen gas react with excess carbon monoxide to produce 6.1 gram of methyl alcohol. Firstly, the reactant which come after the word of excess of, this is not will be enter in our calculation. This is excess. From the equation, it is clear that 2 mole of hydrogen gas will produce 1 mole of methyl alcohol. So we firstly we will convert the number of moles to mass by dividing 2 mole by 2 by 1 to this will be equal 4 gram, and the molar mass of methyl alcohol as illustrated here, which is equal 32 gram. So 4 gram of hydrogen will produce 32 gram of methyl alcohol, but in our example we have only 1.2 gram of hydrogen. So how many grams of methyl alcohol will produced? We will multiply 1.2 by 32 and divide the product by 4, so the theoretical yield will be 9.6 gram. By applying the mathematical equation which is written before, we can calculate the percentage of the actual yield by the division of 6.1 over 9.6 and multiply the product by 100. So the percentage will be 63.54%. This is the end of our lesson today. Thank you for your attention and goodbye.